Welcome back to Namaste Node.js, my dear friends. This is a very important episode in this whole series. I am telling you, whatever I will teach in this episode is very important for your fundamental knowledge of Node.js. We are going to talk about how Node.js works behind the scenes in a much more amazing fashion. Okay? And this episode will lay the foundation of your concrete understanding about Node.js and what are the different portions of Node.js and a lot of groundbreaking things. So focus a lot, keep taking down notes. This is going to be a lot of theory, little bit of code, a lot of diagrams, a lot of concepts. So keep your ears open, listen to each and every word very carefully, keep taking down notes. If you don't understand it in one go, rewatch the whole episode, but this is a very important episode. Don't skip this episode. It is very important for your fundamental knowledge of Node.js. Okay, so let's get started and focus a lot. Listen to each and every word carefully. Okay, let's get started. So, first of all, we have seen the Wikipedia page of Node.js already earlier also. But I have come here to talk about one important thing over here. The one important statement in this whole paragraphs that you see, that is Node.js has a event-driven architecture and capable of asynchronous I/O. Now this is a very short line, but it has a very fundamental, groundbreaking meaning associated to it. Right? If you understand the asynchronous I/O, if you understand the event-driven architecture, you will understand everything inside Node.js. Half your job is done, right? When you will write code, you will realize the beauty of Node.js. You will start, you will slowly start loving Node.js after this episode. Trust me, because your mind will be blown away by a lot of things which I am going to tell you in this episode. Okay, so let's get started. So this whole episode will be around the same concept: asynchronous I/O, event-driven architecture, and what does it mean when I say event-driven architecture? What does it mean when I say asynchronous I/O? Okay, so I will be going very slow and from the scratch, and I will build up things layer by layer. So just keep following what I am saying. Okay, so now let's start with the basic fundamentals of JavaScript. Let's not even talk about Node.js. Let's talk about JavaScript. Right? So JavaScript, as you know, is a synchronous single-threaded language. Okay? A lot of people who have watched Namaste JavaScript, you might have already heard of this, right? So JavaScript is a synchronous single-threaded language. What does it mean? What does this mean? Tell me. Right? JavaScript is a synchronous single-threaded language. Understand this line, fundamental, what it is. The meaning of synchronous single-threaded means that JavaScript, see, whenever you have to run off any piece of JavaScript code, what do you need? What do you need? A JS engine. You are absolutely right. We need a JS engine. So, when I say that JavaScript is a synchronous single-threaded language, that means there is only one thread, and on that thread we are running the JavaScript engine. Okay, assume that whenever you run any piece of JavaScript code, there is a thread, right? In that you run JavaScript engine, and right now it is V8, right? So we are running on one thread, right? One thread is only required to run any piece of JavaScript code. JavaScript in itself does not have a concept of multi-threading or something. JavaScript is a very simple language. Okay, now like a lot of people would be saying, oh my god, is it? JavaScript is so confusing. But this is the beauty of JavaScript, that JavaScript is very simple and it's very complex. It's very simple, that is why it's very complex, right? Because see, inherently JavaScript does not do a lot of things, right? I mean, JavaScript core is not capable of a lot of things, right? I'll slowly build onto these things, right? These things can be confusing a little. But what I'm trying to say is JavaScript is a synchronous single-threaded language, very simple language, okay? You give a piece of code. Suppose if you have a code file, there is a piece of code, right, which is written over here. So JavaScript will execute this code line by line, right? Line by line in a single thread. Okay, so it just has a single thread over here. This is one thread, and V8 engine is running on it. Right now, if you don't understand what is thread, let me explain you in two lines. Right, suppose in the operating system you have a lot of processes, right? So inside the processes you can assume that thread is a kind of like a separate container where you can run any process, right? Where you can run a application, where you can run a program, or like whatever you may call it as a, you can assume that okay, there is a C++ program running in a separate thread. Now there is a concept of multi-threading where you have multiple such threads and they share the same memory and all that stuff, right? So in JavaScript, to run JavaScript, you don't need a lot of threads. You just need one thread. On that, JavaScript engine is running, and JavaScript engine, when you give it a code file, right, it will run your code in a synchronous fashion. What do you mean by synchronous fashion? One after the other. So if you are executing line number 3, then line number 4 can only be executed after line number 3. Right? In the concept of multi-threading or on the other languages, what happens is, see, take a few lines from this code, execute it in some other thread. Take few lines of code, execute it in some other thread. JavaScript does not work that way. JavaScript is very simple, line by line, line number 1, executed, line number 2, executed, line number 3, executed. That's how JavaScript works, very simple way. On a single thread, that's how it works. Okay, and so single threaded, you understood the meaning of single threaded. Now you understood the meaning of synchronous also. One after the other, simple. That's it, right? That's how JavaScript works. But if the language is synchronous single threaded, it cannot do a lot of things. Suppose if there are multiple requests coming in, how would you handle those requests? Will you block these threads? So suppose if something is taking a lot of time over here, how would you handle that? Because you just have one thread. If you do a heavy calculation on the same thread, then your thread will be blocked, right? You will not be able to do things. And JavaScript is not capable of that. JavaScript is just capable of running synchronous code. Okay, JavaScript is capable of running fast code, synchronous code, and JavaScript executes very fast, right? As soon as you give some code to JavaScript engine, it runs it very fast. Very fast. It does not wait for anything. JavaScript engine has no concept of time. Right? As soon as you give it some code, it just quickly executes it. That's how JavaScript engine works, right? I will show you everything in detail using diagrams and all. It took me a lot of time to prepare this, my friends, right? I'm telling you, to prepare this lecture, to prepare this episode, it took a lot of time, but I'm going to explain you in detail. Don't worry about it. Okay? So first of all, before moving on to how code is executed, first of all, I will tell you what is the difference between synchronous and asynchronous. Because I know a lot of people don't understand what is synchronous, what is asynchronous. So many students are there, when I go and talk to them about asynchronous code, so they feel that, oh my God, what's happening in asynchronous, what's synchronous? It's confusing. Okay, so let me just take a layman example and then explain you what is synchronous, what is asynchronous, then we'll move ahead with the code. Okay, so listen to me very carefully. I'll give a very layman example to you. Okay, so suppose you are running a restaurant. Okay, now this is a very crazy example. Okay, suppose you are running a restaurant. Okay, suppose you are running a restaurant, and in your restaurant, right? Sorry for my bad drawing, right? But in your restaurant, you have a counter over here. Here you order stuff, right? Here there is a counter manager and he orders stuff. Now, what all you can order in the menu, we have not kept a lot of things, just 3 things for now, okay? So, there is an option of Coke over here. There is an option of pizza over here. There is an option of noodles over here. Okay? Coke, pizza, noodles. That is all we serve. Now, suppose there is a huge queue over here, right? So, person A, person B, person C, person D, person E, they are waiting to give their orders and take the food, right? That's how things work. Now, before moving on to the queue, let me tell you that, okay, assume that, okay, see, it takes 5 minutes to prepare noodles, right? Suppose if the customer is asking for noodles, so it takes 5 minutes to prepare this. Now, assume that, okay, it takes 10 minutes to prepare pizza, whatnot, right? I am not a restaurant expert, so I don't know how much time it will take, but assume it's taking 10 minutes. And to give, suppose if somebody ordered Coke, how much time will it take? I am assuming 0 minutes, right? You don't have to prepare anything. You just have to go to the dispenser, give it, right? So you can fulfill that order very quickly. Now, so 5 minutes it take for noodles, 10 minutes it take for pizza, 0 minutes for a Coke. Okay. Now let me tell you, give you a disclaimer. This video is not sponsored by Coke. So, but you know, right? I just took an example. This video is not sponsored by Coke. I do not promote drinking any Coke or any unhealthy drinks. So sorry for that. Just to take an example, I have used this. Okay. So now, suppose if this person over here, A, orders a Coke. Okay. Want to get a Coke. Okay. Now, this person B wants noodles. Okay. Suppose if this person B wants noodles. Person C wants a pizza, suppose. Okay. Wants a pizza. Person D again wants Coke. That's it. I am just assuming, making it very simple, that people are not ordering multiple things from here, right? Okay. One person, one thing only. So person A is ordering Coke, person B is ordering noodles, person C is ordering pizza, person D is ordering Coke, person E is ordering maybe suppose noodles again. Right? Want to order. Basically, they have not ordered. Now, first of all, we will understand the synchronous execution. Okay? Synchronous. How things work in synchronous fashion. Suppose if this restaurant is running in a synchronous way, how will these orders be handled? Let me tell you. The person A will go to the counter and say, I want a Coke. Okay? Person A will go and say that, okay, I want a Coke. Now, this order can be fulfilled in 0 minutes, right? The person over there who is standing can just go get the Coke and give it to the customer A, right? This order will be fulfilled in like 0 seconds, isn't it? This order will be fulfilled in 0 seconds, okay? After 0 seconds, this order will be fulfilled. Easy, right? Now, suppose customer B goes over there. Now this order is fulfilled. This A is now gone from the queue. Okay, we have fulfilled this order. Right? How do I represent it? I am just representing it like this. Okay, to the tick. So I know I am messing things up. Okay, customer A is gone now. Okay, so customer A is gone. Now customer B goes. Okay, so now customer B orders noodles. Now, suppose that, okay, this restaurant is working in a synchronous fashion. What does it mean? It can only take the order of C, the customer behind it. It can only take the order of C only once the order of B is finished. So what will happen? The B is standing over there in the queue and then waiting for the noodles to be prepared. And after 5 minutes, right? After 5 minutes, the noodles is fulfilled. So after 5 minutes, the order of B has been fulfilled now. Okay. This order has been fulfilled. Now customer C goes in, right? Now customer C goes in. He was waiting. Now customer C was waiting because this is a synchronous queue. So customer C was waiting over here. Now customer C waited for another 10 minutes because he ordered pizza. So that means after 15 minutes, he got the order. Isn't it? He got the order after 15 minutes. Till 15 minutes, this person D is waiting for his order. Now person D goes into the line. Now he orders a Coke. So Coke is given immediately. Right? Coke is given immediately. So this order is fulfilled in again 15 minutes or something. Right? And for the E, right? For this E, he ordered noodles. Again, he has to wait. And this order will be fulfilled in 20 minutes. And meanwhile, there would be so many more people who would have joined the queue. E, F, G, H and whatsoever, right? Many people would have joined this queue. What I am saying is, this is a synchronous way of dealing with it. Now you might be thinking, now while I was explaining, you got bored, right? You got bored, right? Because this is such a pathetic way of running a restaurant, isn't it? Why is that the other person who is standing in next in the queue cannot come ahead and execute it, right? This person over here, this person D, wanted just a Coke. And he had to wait for this B and C person for noodles and pizza. Like he had to wait in the queue until their order was fulfilled, isn't it? This is a synchronous execution. It's a very poor way of handling code. But let me tell you, JavaScript is just capable of synchronous executions. JavaScript can just execute code synchronously. Similarly, this restaurant is also operating in a synchronous fashion. It's not a good way of operating a restaurant, isn't it? If you have ever gone to, think about it, you ever go to your Pizza Hut or maybe Domino's or McDonald's, right? What do? You go ahead in the counter and suppose you give a order for a French fries or a burger or whatsoever, right? You go to the counter, you give that order. Now suppose you are waiting over there, the next person is waiting till your order is fulfilled. It's a poor way, right? So there comes a way of running a restaurant in a asynchronous fashion. Okay, now let me quickly explain the asynchronous way. Okay, async. Suppose this restaurant was running in a async fashion. How would that work then? Let me tell you. Suppose the person A again orders a Coke, and then the person B ordered suppose pizza. The person C ordered a noodles, and suppose the person D wants to order a Coke, and then again wants to order noodles. So what will happen is, if suppose this restaurant was running in an async fashion, what will happen? The A person goes over here, right? And he gives the order of Coke. So this order will be fulfilled in what? This order will be fulfilled in your 0 minutes or 0 seconds, whatsoever you may write. Okay, now this person A order is fulfilled. Now the person B gives the order of pizza. So now what the counter person will do, he will take that order, go in the kitchen and say that, okay, we have an order for a pizza, right? Now this person B now goes away from the queue and sits in a waiting area or somewhere, right? Suppose if you have a waiting area, right? Let's create a waiting area over here. Waiting area. Okay. Waiting area. And now this person B goes and sits over here because his pizza is getting ready. Meanwhile, what happens is this B person is gone away from the queue. Now C person can order. Right? Now C person can order, isn't it? Now C person has ordered. So when C person has ordered, again, this C person will order noodles, and the noodles order is taken. Now the C person will go and sit in the waiting area, isn't it? The C person will go and wait in the seating area. Now C person is gone from the queue. Now D person can go in the queue. The D person ordered Coke. Now his Coke can be fulfilled at very quick, right? So he's ordered it fulfilled. He does not even have to wait. So his order is fulfilled, right? In 0 minutes. Right? His order is fulfilled in 0 minutes. So meanwhile, this order is fulfilled in 0 minutes. Now, similarly, now the E person goes there and he says that, okay, it takes, right? Let's not talk about how much time it takes, but he gives the order of noodles, and now this queue is cleared, right? And now the person E can go and the waiting area. And now suppose if more people are coming in the queue, F, G, H, they all can also be processed very fast, isn't it? They all can also be processed very fast. Now, what is the order of execution over here? What is the order of execution? Now people are waiting over here, right? People are waiting over here. Now, this B person has ordered pizza. It will take 10 minutes. Meanwhile, the C person has ordered noodles. It just takes 5 minutes. So what will happen? Just after 5 minutes, this order of noodles will be fulfilled, right? This person C will get the noodles after 5 minutes, right? Will get the after up to 5 minutes, right? And this order of C is fulfilled. Now what will happen? Again, after 5 minutes, the pizza is also ready. So and meanwhile, the noodles order was completed, right? The noodles order was completed. The processing of another noodles order, the order of E, started happening, right? At 5 minutes, right? So after 10 minutes, the pizza was also ready and the second noodle order was also ready. Do you understand it? I think it is getting a little confusing to explain you, but you understand it, right? That's how McDonald's and Domino's, Pizza Hut, everything works, right? So in 10 minutes, what will happen? Your pizza will also be delivered and your noodles will also be delivered, and both of them will go away from the waiting area, right? So the order of execution over here is how? So first the order of A was fulfilled, isn't it? Because he ordered Coke, right? Then order of D was fulfilled, right? After that, order of D was fulfilled. He ordered Coke, right? Because the Coke orders are very easy to give, right? It just happens quickly. After D, the order of C was fulfilled, which was noodles, right? Noodles. And then later on, at 10 minutes, the order of pizza and the order of Coke was fulfilled, right? Now they can be in any specific order, right? But let us say that, okay, B was fulfilled earlier, and then D was, and then what? E was fulfilled, okay? So at 10 minutes, both of them were fulfilled in 10 minutes. One order was of pizza, the order B was of pizza, and this was of noodles. So the order of execution was this. But in synchronous mode, the order of execution will always be A, B, C, D, E according to the queue. Right? So this is a synchronous way of running things. This is a asynchronous way. Now tell me, what is a good way of running a restaurant? Synchronous or asynchronous? Tell me. Now, obviously, the answer is asynchronous, because you can do a lot of things in that spacing, and you can also say that this is a non-blocking queue. Don't you think that this is non-blocking? This is non-blocking, and this is a blocking operation. This is a blocking operation. If you understand this example, that's how Node works. Okay, so JavaScript in itself is synchronous, but with Node superpower, it becomes asynchronous. JavaScript is synchronous, but with the superpowers of Node, it becomes asynchronous. Got it? So if somebody asks you, you will say that JavaScript is synchronous. Node.js can perform asynchronous task with the help of some superpowers that we are going to study in this episode. If you understand everything, whatever I said in this video, you will understand a lot of more concepts. Okay. So let's go ahead, and now let us see this restaurant example in real life in the code. Right? You can relate to it. Why I give you this example is, see, it takes me a lot of time to think about how I can explain it in easy terms. But if you understand this, everything will be very clear. A lot of college students are watching my videos. If you are a college student, I am trying to explain you in a very easy fashion so that a kid can also understand what is synchronous, what is asynchronous, and all these things, right? So this is synchronous, this is asynchronous, and it's just pure logic, and that is how we work. Now see, just like over here, we had a task of Coke. So Coke task is very fast, that can be executed very fast. So this is kind of like asynchronous. But the order of pizza and noodles takes some time, that is known as asynchronous code. Okay, so which can happen very quickly, that is synchronous, which will take some time is known as asynchronous. Okay, so that's how tasks are divided into JavaScript also. So suppose, let me give you an example in the code. Suppose if you are doing A is equals to this. I am just taking random numbers. A is equals to this, B is equals to this, and then you are writing a function, you are returning something from the function, you are just declaring another variable and calling this function. All this is synchronous code. And JavaScript engine loves this. JavaScript engine loves this code. Right? Because JavaScript engine can execute this code very fast. This code can be executed very fast. JavaScript engine is very much capable of doing this. JavaScript engine can just quickly execute this code, even though these numbers are very high, right? And then this multiplication of this, the result of this will be very huge, right? Suppose you multiply these two numbers, the answer will be very big, isn't it? But these mathematical calculations are just a child's play for JavaScript, right? JavaScript engine, if you give this code to JavaScript engine, right? JavaScript engine will love this code and it will execute it very fast, right? JavaScript engine is best at doing this synchronous things. But what if you give this to JavaScript engine? What is this code? This code basically is a API call, right? You are making an API call to api.fbi.com to get the secret data. Okay, I have just written it for fun, right? But suppose if you are making an API call, or suppose you are reading a file, right? Suppose if you want to read a file from the system. Suppose if you want to wait for some task, suppose if you want to wait for some task for 5 seconds. So JavaScript engine does not love this code. Because what happens is this type of code blocks the JavaScript engine. See, JavaScript engine wants to keep its queue very clear, right? JavaScript engine is like a synchronous restaurant, right? Synchronous restaurant, and it executes like this. But suppose if the person D is waiting over here and he just was waiting for Coke, it's pathetic, right? So similarly, JavaScript engine will love only if all the orders are coming for Coke, right? But if there are orders which are pizza and noodles, JavaScript engine will not love it, right? Because it takes a lot of time, right? So let me give you an example. This whole code can be executed by JavaScript in just few milliseconds. Just few milliseconds, this whole code can be executed. In fact, a lot of code. Suppose if you give it 1,000 lines of code, but all the code is synchronous, JavaScript engine can execute it like this. In a flash of milliseconds, it can execute this. But these things are slow. API call is slow. Suppose if you are making an API call, then the computer has to do a lot of work, right? It has to fetch the IP address. See, this is a domain name, then domain name maps to an IP address, then go to the IP address, go to the server, and in that server, a response will come. Then the response is passed from the HTTP, right? There is a HTTP protocol, then it will come back to the server, then this will happen. So it takes like 100, 200 milliseconds to finish an API call, right? JavaScript engine does not love it, because it can block, right? So this is an asynchronous task. This is an asynchronous task. Asynchronous tasks basically are which takes time, right? These tasks take time. These tasks take time to execute, right? Takes time to execute. And these tasks can execute immediately, and JavaScript engine loves it. JavaScript engine loves these kind of synchronous code, right? And JavaScript engine does not want to do these heavy asynchronous tasks. Now, but in Node.js, via Node.js, we can do all these things. We will see in going for future in this episode only. I will tell you how all these things are executed in a very fast way. Okay. So this is the beauty of it. Now, let us first of all see that how synchronous code is executed in JavaScript. Okay. So now let us just quickly see how synchronous code. Okay. So this is synchronous code. Let us just see how this code is executed by JavaScript engine, because if you understand this, you will understand this asynchronous also, because a lot of people don't even understand how this code is executed. Okay. So, I'm telling you, my dear friends, whatever I am teaching you in this video, this is very, very ground level things, what happens, right, inside, right? How your code is executed. If you understand all these concepts, your fundamental knowledge will be, good, right? So let me just tell you how this code is executed. Now this is all synchronous code, and it will be executed in the JS engine, right? So JS engine loves this type of code. And let me first of all tell you how this code is executed inside the JavaScript engine. That is when you will love it. But before moving on to running any piece of code, let me tell you what all portions are there inside JS engine, right? What is JS engine? What it internally has? So JS engine has a call stack. And this whole thing is running on a thread, on a single thread, THREAD, right? So this whole thing is running on a single thread, right? So it has just one call stack. JavaScript engine just has one call stack, and every code that you write is executed inside this call stack over here. This is the place where all your code, whatever code you write in JavaScript is executed. Whatever Node.js code, whatever JavaScript code, everything is executed inside this call stack. Everything. Now, JavaScript engine also has a memory heap, right? Whenever you do var a is equals to 10786, where do you think this memory? So this memory heap allocate a variable a over here, right? Allocates a variable a over here, and it puts this value over here, right? So this 10786 will be pushed inside this memory heap, right? So memory heap contains all the numbers and functions and whatever you have to store in variables, whatever you have to store in memory, it is there inside JavaScript V8 engine. Now JavaScript V8 engine also has this garbage collector, right? This garbage collector, because see, whenever you your see, suppose you created a variable A. Now you have used the variable A. Now suppose later in the program you don't have A, like you don't use A any further. So what will happen is the memory will be clear, because JavaScript engine has to manage all these things. So JavaScript engine has a garbage collector which collects the unused variables, unused functions, whatever is done. So it keeps on clearing the memory. Let me tell you, in languages like C and in languages other low level programming languages, you have to manage your own garbage collection, right? We as programmers have to allocate memory and deallocate memory. Otherwise, it will consume a lot of memory. But in languages like JavaScript, right, all these complex things are put inside the engine, and we just write our normal code. We just define variables. We don't think about whether we should collect the garbage or not, right? It's like in JavaScript, you litter as much as you can, and there is a garbage collector. It will just collect all your litter, that whatever you have done in your code, right? You can just put rubbish into your code, and then garbage collector will come and collect your rubbish, right? It does not matter. So that's how JavaScript engine works. So garbage collector works in sync with this, and it keeps collecting garbage, right? At some point of time, right? It just keeps collecting garbage as the code is run. See, inside JS engine, it's a program. After, at the end of the day, you know, right, what is JS V8 engine, right? V8 engine is kind of like a C++ code. It has to do garbage collection, it has to manage memory, it has to manage the call stack, and all the code that you pass and run inside this call stack. Okay, so this is V8 engine. Now let me tell you how this code, suppose if you pass this code, how this is executed inside this call stack. So whenever you pass the code, so all the code that you pass in, suppose you pass in some JavaScript file, suppose you pass in this much code, right? All this code is run inside this call stack, inside a global execution context. Whenever you run this code, a global execution context is created and pushed inside the call stack, right? So this global execution context is created and it is pushed inside your call stack. Now all this code is wrapped and is executed inside this execution context. Okay, now this code is what? Running in a synchronous single threaded way, right? It runs in a synchronous single threaded way. What does it mean? That it will execute one line at a time. So first this line, then this line, then this line, then this line, something like this. Okay, and it will use memory space, it will do garbage collection and all that stuff in parallel, right? JavaScript engine is just taking the code and executing very fast, very fast, very fast, right? Like this it executes. So it is executed line by line. So first this line will be executed, A will be stored inside the memory, then this line will be executed, B will be stored inside this memory, then this line will be executed, this multiply function will be stored inside this memory. Now at this point of time, this code will be also stored inside this memory. This will not run. This will run once you call the function, right? So what will happen? This line will run, this line will run, this line will run, and it will add all these things into the memory heap. Now what will happen? We'll move to this line. So now where C is that, okay, there is a function call. Whenever there is a function call, whenever you call any function, one more function execution context is created. Now an execution context is created, and this functional execution context is pushed inside this call stack, right? So now the call stack does not push out global execution context because the code is still running over here, but is pushed the functional execution context, and whatever is there inside this function, right, this function code will now be running in this execution context, right? Will now be running in this execution context. Now how will this code run? This code will also run in a synchronous fashion, line by line, okay? But this code will run, whatever is there. Now this line will be executed, this line will be executed, and the result of A plus B will be stored in the memory heap. Now this line will be executed, return statement. So whatever is there in the memory heap will be returned back from this execution context to the global execution context. And once the execution of this function is completed, what will happen is this function this functional execution context, after finishing its job running a function, moves out of the call stack. It is popped off the call stack, right? It's popped off the call stack. Okay, so now let me remove it from the call stack. Okay, and then the global execution context where it left at this line, will again start running. So now the multiply function returned the value of this result, and that result will be now stored in C, and then this C will be stored in C. Once the whole code is executed like this, what will happen is global execution context is also gone away from the call stack, and the call stack will become empty. Okay, after running all the code, this call stack will become empty. Do you understand this? Do you understand this or not? If you haven't understood how this code is executed, I would request you to please go back and watch this video once again. Go back, rewatch it. You will understand. You should understand how this will work, right? So if I have to recap, let me just quickly recap it very quickly, right? So that it just, I explain something and then I re-explain something. This is my bad habit as a teacher, but it is a very good habit for you. Why? Because when sometimes people say me, sometimes a lot of students say me that, Akshay, why do you repeat so many times? See, I can just quickly finish this episode and I can move on to another video. It is pain for me to keep repeating things, and I repeat only those things which are very necessary. Right? I could have skipped, I can move to the next topic, but I am repeating this concept over here because this is very important. And when I repeat these concepts, it sits in your head. Right? As a teacher, I love repeating things. As a teacher, whenever I have to, as a teacher, I can control your brain, right? Whatever story I am telling you about JS Engine is fitting into your brain, isn't it? That is a job of teacher. And if I am repeating it, that story is just getting strengthened in your brain. And that is how I teach. That is my teaching style. That is why so many students love me, right? So let me repeat it. Whenever I repeat anything in the video, don't feel that, okay, Akshay is just boring us. I am repeating it for a purpose because that thing is very important and that needs to be repeated. Okay, so don't worry, let me repeat it once again. So whenever you run any piece of JavaScript code, this whole code is executed inside the call stack, inside a global execution context. A global execution context is created and it is posed inside the call stack. Now each and every code is run line by line in a synchronous fashion. This code is run var a is equals to 10786 and it is stored inside the memory heap. B is stored inside the memory heap. This function is stored inside this memory heap. There was already global execution context, right? So functional execution context will now run this code. Now this line will be run over here in the functional execution context and the result will be returned. Now what will happen? This result is returned. So this line is executed now and that result will come inside C. And now in this global execution context, this C will be allocated memory over here. Once all the code is executed, your global execution context moves away from the call stack. And I have taken so much time in explaining this, but JavaScript engine, when you will give this code, JavaScript engine will do all this processing in just millisecond. Just millisecond, maybe in half a millisecond or something. I don't even know the numbers, but that's a very small fraction of a second. Very small second, right? It will do. Even if you give thousands of lines of code, it just executes it like this, right? You won't be able to see also, right? It just goes into the stack and it happens, right? The code is run. JavaScript does not wait for anything, and that is why I have a quote also when I say time, tide, and JavaScript waits for none. Okay, so I say this to all my students: time, tide, and JavaScript waits for none, right? JavaScript engine takes the code and executes it very fast, and that is why it loves it. If you ask JavaScript engine to wait for something, it will not do it. It does not know how to do it. It's not good at it. Okay, so this is how synchronous code is run, and this is how this code JavaScript loves it. Right? Now, hope you have understood this. Right? So now let me go ahead and show you that how asynchronous code is run. Right? And how JavaScript engine deals with asynchronous code. What happens? Because see, When you are writing Node.js code, you just don't write all the synchronous code. There can be API calls in between, there can be file handling in between, there can be so many things in between. How does JavaScript engine execute all of this? Right, let me just explain you now in the next slide. Hope you have understood this. If you have not understood till this point, go back, rewatch the video and then come back over here. Right, let's go and let me say that, okay, see, JavaScript engine job is not just to run synchronous code. JavaScript engine is good at running synchronous code, right? But what if there are asynchronous tasks which takes time, right? What if JavaScript engine has to go and talk to the file, read the file? What if JavaScript engine has to read the database, store some value in the database, or get something from the database? Suppose JavaScript engine has to make an API call from the web www network, right? It has to go fetch some data from the network, get back the data. What if JavaScript engine has to get the timer? See, this timer can be a little confusing for a lot of people. Whenever I say timer, that means that, okay, see, JavaScript engine in itself does not have a concept of time. JavaScript engine, you just give it JavaScript code, it will execute it. It does not know how to wait. It does not know. JavaScript engine can't wait. If you will ask JavaScript engine, if you will give some code to JavaScript engine and say that, okay, wait for 5 seconds and execute it later, right? How do you do that? If you use a set timeout, right? If you use a set timeout of 1000 milliseconds, that execute this code after 1 millisecond, or 1000 millisecond means 1 second. Execute this code after like 5 seconds. JavaScript engine does not know how to do it. It's alien for JavaScript engine. JavaScript engine just give it some code and it executes it. It does not have a concept of timer. Whenever I tell all these small things to students, they are amused. There are so many senior developers who are writing JavaScript since so many years, but they don't know about these small things. JavaScript engine does not have a concept of timer. JavaScript engine cannot wait for anything. JavaScript engine, time, tide, and JavaScript waits for none. It cannot wait. It does not have. It just waits for none. You give it some code and it executes it. That's how JavaScript engine works. It does not have a concept of time and timers and all. So these are the superpowers you need. If you want to do all these things, you need some superpowers, right? And JavaScript engine cannot do this alone, right? That is why Node comes into picture, and Node gives these superpowers to JavaScript engine to interact with the operating system and do that. Do you understand that? Now, I am slowly, gradually increasing the things for you. Now, what happens is, JavaScript engine can only do synchronous things. JavaScript engine does not have superpowers. JavaScript engine, see, where is this file? This file is sitting in the operating. See, suppose if you have to access a file, on the server, suppose if you have a computer, if you want to access a file, read a file, so JavaScript engine needs to talk to operating system, right? Because operating system at the end of the day knows the location of the file. Suppose if you are using a Windows, then which drive it is in C drive or D drive, or at which folder path it is, which directory it is, where is that file. All these location can only be get through OS. So somehow JavaScript engine will need to contact the operating system to get the location of file and get the data from the file. Right? Now JavaScript engine does not have any capability of database to connect with database, but JavaScript engine needs some superpowers to connect with database. Similarly, JavaScript engine does not have concept of time. It needs to connect to the time function inside the operating system, because operating system manages time, right? Right? The concept of time, operating system can make a network call. It's not happening inside Node, or it's not happening anywhere. All these things are managed by operating system at the ground level, right? There is an operating system, there are kernel, there are processes running on it, and there are ports, and so many things are there in operating system. But you need JavaScript engine needs some superpowers to get access to all of this. What are these superpowers? These superpowers are given to JavaScript engine by Node.js, and Node.js is doing that by a library. Let me just show it to you. These superpowers are, these superpowers can only be managed by a superhero. Who is our superhero over here? Right? You need a superhero to do all these things. Right? You need a superhero who can connect this V8 engine to the operating system. Right? You need a superhero over here. And that superhero for us is libuv. With a big round of applause, let us welcome our superhero, which is libuv. Okay? Now, I am just adding more complexities to this. But, libuv is a very core thing inside Node.js. libuv is our superhero, right? libuv is our superhero. And suppose if JavaScript engine needs to make a file access, it cannot directly do it. It says that, okay, you need to do file access. It tells libuv, and libuv talks to the file system, gets back the response, give it back to the V8 engine. Does it make sense? Suppose if you have to make a network call, V8 engine says that offloads. V8 engine just offloads everything to libuv, and libuv is like a superhero. It's like a genie for you. Okay, it is like a genie. You can, let me just write it up. Right, libuv is a genie for us. Right, he is like a genie for us. Do you know the concept of genie? If you don't know about it, it's a genie for us. Right, it's a superhero for us. It's a assistant. Not even call it assistant. Assistant is a very low quality word. Let's call it a genie. You just rub the Aladdin's chirag, and then a genie will come up, and then genie can do a lot of things for you. Genie can talk to you on behalf of genie can talk to the OS on behalf of you. Genie can just go and make the network call. This libuv can just go and talk to the timer, right? Genie can do a lot of cool things, my dear friend. Okay, libuv is a superhero for us. It's a superhero, and he has superpowers, and it can do a lot of cool things, right, my dear friends? Okay, so libuv, if needed, can talk to the timers, can make an API call, can read the file, can talk to the database. It can do a lot of things. And whenever the responses come, it just gets back these responses and give it back to the V8 engine. So what V8 engine does is it just offloads a lot of tasks to libuv. Whatever V8 engine is doing, it just offloads those tasks, right? So offloads asynchronous tasks. And see, synchronous code, it can beautifully execute, but all the asynchronous code, V8 engine just offloads it to our libuv, and libuv is like a genie. It just goes and do whatever you say, right? It obeys your order. It's like a free superhero for you. It's like a Doraemon for you, right? It does a lot of things, right? If I have to relate it, it is like, you can assume that, okay, it's like so you can assume that, okay, this V8 engine is like Narendra Modi and libuv is like Amit Shah. Right? Okay, I should not make political jokes over here, but assume it like this: offloads libuv, and it just does all it things, right? So basically, you can also assume that, okay, if you have played chess, right, in the chess, you can assume V8 engine is like a king, and this libuv is like a queen, right? So basically, king does not do anything, right? He just sits in the chess. He just do small stuff, right? He can just move in one block at a time, right? But then there is a queen which can just go in any direction, can do a lot of things, random things, right? So all the superpowers are there inside libuv, and it does that, right? And the V8 engine is just sitting over there doing the fast stuff, right? You can just do quick stuff, right? All that stuff. So I know these are bad examples to relate to, but what I am trying to say is JS engine can just do synchronous things. Most of the asynchronous things are offloaded to libuv, and then libuv has some superpower. It's like our genie, and it does all that thing. Hope you have understood this. If you haven't, go back, rewatch the video, and now we will go ahead and actually see how libuv is doing all this. Are you interested or not? Are you interested or not in knowing that? And are you seeing that amazing superpowers of Node.js? Now you understand that why Node.js comes in. Node.js uses V8 engine. Node.js has some superpowers. This is libuv, my dear friends. This is libuv. libuv. And now you might be thinking that's a very poor name, right? That's not a very fancy or a very good name. But assume, right? It's a libuv and it's a genie for us. It's a superhero for us, right? And now do you see this? Now I will show you how asynchronous code is run. But before that, what is this dinosaur kind of a thing? What is this? This is not even a dinosaur. This is a unicorn, my dear friends. Do you see? This is V8 and this is your libuv. This is your libuv, right? Now you might be thinking, Akshay, why are you kidding me? What is this unicorn? What is this dinosaur? And there is operating system with all these things. What is all this? Let me just show it to you. Don't you worry. Let me go to the browser. Where is my browser? Okay, I don't have a browser. Let me get my browser over here for you. And let me show you the libuv, right? So here is our browser. And if I search for libuv over here, let me just show it to you. If you search for libuv, it is a multi-platform C library that supports for asynchronous IO based on event loops. You will not understand the definition right now. Don't worry about it. I will just explain you. But let's go to the official website of libuv. So see, libuv has the logo of libuv is this unicorn. Okay, this is libuv. Okay, now this libuv handles a lot of tasks, right? I will just explain you in detail also what it does. But it says that asynchronous IO made simple. So asynchronous tasks for V8 were very complex, but with libuv, your asynchronous IO has become very simple. Okay, listen to this very carefully. It just says that async IO made simple. Basically, if you will use our library, so V8 engine can just make its async task simple because it can interact with operating system. There is a lot of code. And what is libuv at the end of the day? At the end of the day, libuv is just some piece of C code, my dear friends. It's just some piece of C code. Just like V8 engine is written in C++, it has C code. Similarly, libuv is written in C. It's just a C program. It's just a C code. It's just a C library written in C language, right? You don't understand this. These things look very fancy. It has a fancy like logo over there. There's a unicorn and all that love. But you will go to show me the code. You will see it's just a C library over here. See this. 97% of the code which is written in libuv is written in C. It's written in C. I told you, right? JavaScript is a high level language. To connect with operating system, do you remember in one of the earlier slides I told you one important concept of machine code, and then there was assembly code, and then there was high level, low level code and all that stuff I told you? Similarly, JavaScript is a high level code, and operating system, to connect with operating system, you need a low level language, which is C. C language is very efficient to talk to operating system. That is why this library libuv, libuv, libuv is written in C and it talks to the operating system. JavaScript talks to libuv and libuv talks to operating system, gets back the data and gives it back to. So basically libuv acts as a middle layer between your JavaScript engine and your operating system. I cannot explain this concept in an easier way than this, my dear friends. I am telling you, I have also watched a lot of Node.js courses. I have also read a lot of Node.js blogs. But this is the simplest explanation you will find on the internet, and I am telling it with a confidence, my dear friends. I am making this Namaste Node.js series to explain you each and every minute details about this subject. You know, it's very tough for me to make all these diagrams, explain it in a story form, explain it slowly. I am building things up, right? Lot of things you have learned, and if you will dive deep into libuv, there is libuv is huge, right? libuv is huge, and I will make a separate video on just explaining about libuv. You know what? libuv has a thread pool. libuv has a event loop. Have you heard of event loop? Event loop in Node.js is there inside libuv. The thread pool is there inside libuv. libuv has a lot of cool things, my dear friends. libuv has a lot of queues inside it. It has a IO callback queue. There is a timers queue. libuv manages your set timeout. libuv manages your timers. libuv manages your file system. libuv has a lot of access. libuv, my dear friends, is a genie for us. libuv is a beast over here. libuv is a genie for us. Right? I am not sure about the spelling of genie, but it's a genie for us. libuv is our superhero. Right? So, and let me tell you that it's one of the most important libraries inside Node.js, and it deserves a lot of respect. Node.js is fast. Node.js is asynchronous because of libuv. We will understand this in very small, but why I am taking a lot of time over here is so that you give importance and respect as a developer to libuv. It's like whenever there is a very good movie that you see, we all appreciate the actors, right? We say that, oh my God, Shah Rukh Khan's performance is very good. Obviously, actors have their own respect, but nobody is appreciating, right? A very few people are appreciating directors. But director is the one who is sitting on the ground and managing everything and who has put in all the efforts to build the thing, right? But we appreciate the actors or somewhere, right? So what I'm trying to say, libuv is kind of like an unsung hero, right? It's a superhero, which nobody appreciates it. Whenever I go talk to people, Node.js developers, nobody knows about libuv. They don't know. They just write this code and they don't know what happens behind the scenes. They have never not heard about libuv also, right? But this is why I want to take a moment and appreciate libuv. And now, this is, as I told you, it's just a C program. Now let me also show you Node.js repository and where libuv exists, right? At the end of the day, Node.js is what? Node.js GitHub, right? If you'll go to GitHub, yes. At the end of the day, Node.js is a C++ program. And we saw this repository already, right? See, why I am telling you these small things is so that you don't confuse. You know the reality what is happening, and you also know the ground level fundamentals. Okay, so whenever you go to lib over here, these are the libraries, or sorry, I think in dependencies. If you'll go to dependencies, so you know, right, there is a V8 engine. See this, there is a V8 engine. This is what? This is your JavaScript engine over here, right? If you go to this repository and you go to the deps, this deps are dependencies. If you'll see the dependencies of Node.js, so there is a V8 and there is a Google JavaScript engine over here. Similarly, you have UV over here. This UV is the libuv. If you will go and see, this UV repository is the libuv over here. It is existing as a dependency. At the end of the day, it is just C repository. It's just C code, C language code, which is present inside the Node.js dependencies. This is what libuv is. This is libuv. This folder, this C code is libuv. Whenever, and this is your V8 engine. V8 engine is very good. This C++ program V8 engine is very good at executing synchronous code. And whenever it finds asynchronous code, whenever there is something asynchronous, it offloads it to libuv. And this libuv code then talks to the operating system, gets back the result and give it back to V8 engine. Do you understand this? You have to know the ground reality also, what is happening when I am making this diagram. Some developers knows all these concepts just by diagram. Some people know just by code. I am telling you in everything like how things work behind the scenes. I am telling you, go to people who already are experienced developer, Node.js developers, and ask them all these things. They don't know much about it. They don't know much about it. I want my students, every Namaste Node.js graduate, if you have watched this series, should know how Node.js works behind the scenes. When you will learn all these concepts and when you will go in the interview, then you can just challenge the interviewer also. You will get confidence when you understand all these concepts, that you understand how things are working behind the scenes. That is why I teach you. I want my students to make me proud, to know how things are working behind the scenes. There are some developers who are again the unsung heroes who have written these libraries. There are developers who are writing this code for making our life easy. There are developers who are building this V8 engine, managing this garbage collection so that we as a developer don't have to manage garbage collection. Garbage collection is such an important concept in C. If you write code in low level languages, you'll have to collect your own garbage. We never think about that when we are writing a JavaScript program, right? We don't think about memory optimization and all these things. But always give appreciation where due, and I want to appreciate libuv because it exists inside Node and it makes Node powerful. Node.js is just a compilation of everything, right? Node.js is a beautiful library out there, right? Which just have a lot of managers, right? These are different managers over here, and just like a company cannot run without a CEO or a CTO or a CPO and all that stuff, similarly you can assume that if you have to run Node.js, you need these main managers to manage all these things, right? This is a synchronous code manager, this is a async code manager, so many things are there. And not just these components, Node.js has a lot of other core modules and dependencies. Don't think that, okay, these two are heroes, but there are a lot more people who are lot more things, lot more libraries who are working behind the scenes inside Node.js. I have not made those libraries inside this diagram, but that does not mean they don't deserve attention. They also are very, very important. But two major things are V8 engine and libuv inside Node.js. So now let me not spend more time over here. Let me move ahead. So what happens is, whenever JavaScript engine, see, all the code that you write is there executed inside V8 engine. You know that inside the call stack. Now, whenever the call stack, whenever the JavaScript engine, whenever the V8 engine sees a API call, this is an API call, right? Whenever he sees that file read operation, suppose there is a file read operation, wherever he sees the set timeout, so it offloads these code to libuv, and then libuv manages it somehow, right? It talks to the OS sometimes, it does not talk to OS sometimes, whenever it requires, however you want. Basically, libuv is like a genie to V8 engine, right? Whenever there is some async task, so V8 engine will just call the genie and then say that genie execute this, and then genie will just execute it and give it back, right? So what will happen whenever you have to make an API call inside V8 engine? V8 engine sees that, oh my god, it's an API call. So API call, libuv, make an API call, get the data, however, right? Now libuv works behind the scenes, it talks to the OS and does a lot of things, and then gets back the data and then gives it to V8. And then whenever it gives it back to V8, V8 engine executes it, right? V8 engine executes it. I will show you all this happening inside the code also in a code walkthrough. Okay, are you ready? Are you ready or not? Hope you're not getting bored. I have tried to make it as interesting as possible. It's very tough for me as a teacher also to make these entertaining and educational videos at the same time. It's very tough for me. If you like these videos, please, a small request that if you can just give me a shout out on LinkedIn, on Twitter or social media, it would mean a lot to me. Just tell about these courses to your friends, family. That will be like a appreciation for me, and that will be a huge help. It takes a lot of time, my dear friends, to prepare all this concept and, to explain it in an easy way so that you understand it, right? Teaching is not easy, right? It's tough. It takes a lot of time. I have been preparing since so many weeks, so many months to just get all these content aligned, and it took a lot of time for me to release this course also, just because it takes a lot of time. It looks very easy that okay, you just have to sit in front of the camera, make these videos and all. No, my dear friends, it's not that easy. It's not that easy. Anyways, chalo, let's go ahead and let me just show you how things work. Now let me just show you that how. This is the last part of this episode, okay? Hope you are watching it and hope you are not bored. Please give me just 10-20 minutes more and I will explain you these things, because if I stop the video over here, you will just go off and you will forget everything. I want it to stick inside your head. That is why I'm telling you everything slowly back again. Very important video. Okay, so let us just continue with our episode now. So here we have libuv. Now we will see how the mixture of synchronous and asynchronous code. See, there is a synchronous code, there is a async code. Everything works inside Node.js, right? Everything, how this whole code is working, where we are reading the file also, where we are managing everything and all that stuff. How does it work? Everything we will see. Okay, so let me just show you how this program is executed. This is a Node.js program. How Node.js, suppose if you give this file to Node.js, how it runs. I will show you in form of a diagram and your mind will be blown. Okay, so you will start loving Node.js when you will see all these things, how things are happening. You will start loving Node.js, I'm telling you. You will understand that libuv is a beast. Libuv is our genie, and libuv is our superhero with all these superpowers, my dear friends. Okay, so let's just go back and execute our code. Now you know a lot of things, how it works. I will just quickly tell you. Suppose if you are executing var a is equals to this, so this var a goes and stores inside the memory heap. Now you know, right? I don't have to explain you again everything, but let me just quickly give you a recap. Whenever you run any piece of JavaScript code, it goes to the global execution context. It creates a global execution context, and everything, whatever code you ever write in Node.js will be run inside call stack. Whatever code you will ever write in your Node.js program will run inside a call stack over here, right? Over here, every code will run, and there will be a global execution context which will be created inside this call stack. If I go over here, so let me just create it up for you, okay? So there is a global execution context which will be created over here inside your call stack. Okay, so let me just show it to you, okay? It will take some time. It might take some time for me to explain you this, but listen to me very carefully. It took me a lot of time to explain and make all this in diagrams and all, right? So please give me your like 10-20 minutes. I want to explain you in a very good way, right? If you will understand this, you will understand a lot of things, my dear friends. You will love Node.js, and I want, whenever I teach something, the main goal is to make my students love the subject. Who is a very good teacher? A good teacher is who can make you fall for the subject. I, as a teacher, want to make you fall in love with Node.js, and this is my mission from this Namaste Node. The main mission of this Namaste Node is to make you fall in love with Node.js and how things work inside Node.js. So that when you write Node.js code, you appreciate, you feel amazing as a developer, and in your head, you feel that, oh my God, so many things are happening, right? You will understand the beauty of it, right? So, okay, so now what happens whenever you run any piece of JavaScript code, a global execution context is created, and all this global execution context is pushed inside the call stack. And in this global execution context, the JavaScript code is run in a synchronous single-threaded fashion. What does that mean? It runs in a synchronous single-threaded way. That means it runs in line by line. So this code is executed line by line, one line, one line, one line, one line, one line. Like this, the code will be executed line by line. And when you do var is equals to this is a synchronous code. JavaScript engine will just allocate some memory over here to variable a over here. And then what will happen? This garbage collector will also work in sync, right? Garbage collector will work in sync with this memory heap, and it will also keep collecting the garbage. Meanwhile, you are writing the code and executing the code.